and it kind of works faster when you do it that way. So you just keep thinking 4 times, 4 times, 4 times. Notice it finally changed right around here. Oh, the 0 is the root of 4x, so it changes around its own root, right? You can't change around somebody else's root. You can change around your own root. Sometimes you don't, but if you're going to change, it's around your own root. Okay? Now, negative 1,000. All right, negative 1,000 squared. Gigantic positive number, right? And it's 4 minus gigantic. That is negative. Okay? You don't have to think about 1,000 squared. Just think about huge. All right? Now, negative 1 squared is 1, but it's 4 minus 1.
Negative.
So it is positive. And isn't this also 4 minus 1?
Yep, positive.
Still positive. And then 4 minus 100 squared, definitely negative. See where it changed? Negative, oh, positive, stayed the same, oh, changed again, right around its own roots. Once you transgress the root, if you will. Okay, pass the root. All right, so plus, minus, plus, and minus. So if the first derivative is positive, negative, then the original function is something increasing. Increasing to negative 2 comma I don't know. Decreasing to 0 comma I don't know. Increasing to 2 comma we don't know. And decreasing. So it does make an M shape, doesn't it? Okay. I'm not running for president, okay? This is Richard Nixon. It's a long time ago. Okay, some of you know who it is. All right, he's a president. Okay, anyway, I'm so surprised. Of course, we're not, right? And if you look right here, what does x to the 4th make? That is a parabola. But if you put a negative on it,
What's it?
upside or concave down parabola, x squared, bend in the curve, makes an M shape. There we go. Okay? So we were hopefully expecting that, or once you see it, you go, oh yeah, of course, yeah. Okay, now I drew this jagged, of course, just draw a little jagged sketch, but in actuality it's smooth, right? It's a nice smooth end, okay? All right, so we're looking for the what? The x-coordinates, the relative maxima. So, how many relative maxima do we have in this problem? We have 2 peaks. They're in there, so list them both. So actually, it just says the x-coordinates only. So you can just list negative 2 comma 2, or if you really want to press Mr. Wade, plus or minus 2 would be there. Okay, and there you go. Don't use the 0 because the 0 is a value where only the peaks are. Okay, so don't use that.
So the answer is just plus or minus.
That's it. We're done.
So just plus and minus. X equals plus or minus.
Yeah, preferably x equals at least put plus or minus.
If they wanted us to find the y, then we'll just put it back in.
Yeah, if it just says find the relative maximum, but it doesn't say x coordinates, you want to go back and find the y coordinates. There will be a couple of these where I just do a time saver for you and just say, you know what, skip the y coordinate this time. You know, just give you the x on it. Okay. All right, here's this one. This one's probably the longest one, I think, on the front page. But let's get our 5 points right here. Okay. Oh, Mr. Wade, you gave us so many fractions. Well, first of all, remember that fractions are your friend. That's right. Decimals are, we're dangerous. Okay, I didn't actually say that, parents. Okay, so, all right, so let's take a derivative here and let's see what happens. So that's going to be 6 times, oh, you know what? Not only are fractions our friends, but Mr. Wade handcrafted this one right here. That's x to the 5th. That cancels, that's 4x to the 4th. That cancels, that's x to the 3rd. And this cancels, that's 4x squared. Nice. Okay? Now, if you have all these terms, you could do that one problem from the back page where you do the rational root theorem. Thank you to our Frenchman, René Descartes. Okay? Or you could not do the rational root theorem and do the long division, remember all that long division and all that stuff? You could not do that because I did set this up to be what? 4 terms, factor by grouping. Yep, always check that first, because a lot of times it's just factor by grouping. Very rarely is it actually the rational root theorem. That's like the worst case scenario. So, in this case, why don't we take out something from the first group, namely x to the 4th, let's take it all out, sure. X to the 4th, x minus 4. Second group, Let's think of an x squared. And, you know what? In fact, by grouping, if you ever lead off with a negative in your group, take the negative with it. I would take out negative x squared. Definitely. Okay? Now, negative x squared, think about distributive property. Negative x squared times blank gets me back to negative x cubed. X. Negative x squared times blank gets me back to positive 4. Negative 4. Oh my gosh. I just won the lottery. Ding, 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 ding. Okay? It's like getting bars all the way across, or lemons, or whatever it is. But whatever you're supposed to get on the little slot machine. Okay, I got a match, and that's good news. Because that means you did factor by grouping correctly. And then you can take out the GCF of not each group, but the whole thing. What does the whole thing have in common between the two groups now? X squared and x minus 4. And you are lottery winners in pre-calculus. Okay? It's almost as much fun. Not quite. All right, so if you take out x squared, slice and dice, the only thing left over in group 1 is squared and b minus 1. Okay? Oh, thank you, Miss Sabina. You're welcome, kids. You're supposed to say okay. Yes, you're welcome. Students, you get a nice little difference of two squares right here. So you get answers of 0, 4, and plus or minus 1. Okay? How many answers do we get here? 4. So we got 4 critical numbers. All right. Let the record show I'm walking over to an imaginary test. Okay? Let me just put this on my imaginary test over here while YouTubers stare at a blank board. Okay? Oh, but wait, kids. Guess what? There's more. Those are called critical numbers, but we're looking for relative extrema. And there's one big difference between critical numbers and relative extrema. They can't just be the roots of the derivative. They must also have a what? They must have a sign change, a slope change. They have to. What are relative extrema? All the whats and all the whats. All the peaks, all the valleys. To be a peak, don't you have to have a slope is positive to slope is negative? To have a valley, it's slope negative to positive. One of those, or several of these, might be a false reading where you get a plus plus or a minus minus. That's not a peak or valley. Okay? So, let's check it out. Well, who's the smallest here? Smallest one would be negative 1, then 0, then 1, and 4. All right? Sample comment. Okay? What is lower than negative 1? Okay, negative 1,000. Ooh, tight squeeze here. No integers, so let's just use negative 1/2. Positive 1/2. 2. And? Okay. Yeah. All right, so pick your sample points. Now, remember, and by the way, don't make marks. Sometimes people make marks for their sample points, but don't do that. Just leave marks for the critical numbers only. Those are dividing the worlds of plus and minus, right? Okay? So that all the red numbers I just put in should give me either a plus or a minus. Never put in a sample and get 0 or does not exist. You did something wrong. Okay? These are pluses and minuses. Okay, let's attack this by group. X squared. Negative 1,000 squared is? Oh, so the first one's going to be plus. Isn't anything squared always positive?
Yeah.
So all the way across, I'm going to get plus blank blank plus blank blank all the way through. Okay? All right, so far so good. And by the way, let me let you know a little secret, okay? It's between you and me and everybody who watches YouTube. The little secret is this. If x squared is always positive, does the plus sign actually change signs? Only a negative sign changes signs, right? A positive just keeps things the same. You know, you can actually just not even put the pluses at all. If it's always plus, it doesn't have any effect on the sign. So if it's always positive, you can just skip it, and it works the same way. Now, negative would be important. You can't skip a negative. But a positive, forget about it. Okay? Just make it disappear. All right? Now, middle parentheses. Negative 1,000 minus 4 is negative. Negative 1/2 minus 4 is negative. 1/2 minus 4 is still negative. 2 minus 4 is still negative. Oh, I haven't something transgressed. I haven't transgressed the root yet. When you get to the other side of 4, and that you were trespassing, as they say in England. Trespassing, all right?
Trespassing?
Yes, that's what they say in England, yeah, trespassing. Now that you trespass, or surpass, or transgress the 4, you get a plus. It works. All right, next one. -1,000 squared is gigantic, right? Negative a half squared is only a 4. Yeah, that's gonna be negative. 1/2 squared is also a 4. Negative. 2 squared is 4. Oh, again.